Hello, everyone. My name is Sina.
My name is Miriam.
This is our presentation for the final project for time series analysis. The data we are working on is the monthly turnover of the food retail industry in Australia for the years 2019 to 2023, taken from the website abs.gov.au.
We first converted the data into time series and plotted it. As seen in the plot in figure 1, the plot shows an upward trend and no repeating patterns, and hence there is no seasonality. There are some fluctuations which indicate that there are slight changing variances. The plot shows an autoregressive behavior as the points tend to follow one another. A change point has been observed in the first half of the year 2020, after which we see that there is an upward trend. From the ACF plot, we see a decaying pattern, and PACF plot shows the first lag as a significant lag, and hence this suggests that series is non-stationary. From the QQ plot and the Shapiro test, it can be seen that the data is not normally distributed. The ADF test also confirms that the series is non-stationary, but the PP test says otherwise. However, looking at the time series plot, the ACF and PACF plot and the ADF test, we can confirm that the series is in fact non-stationary.
Here we perform the first differencing of the Box-Cox transformed series, and we can see in figure 7 that the series is stationary. The ACF plots further confirms this as there is no more decaying pattern and shows the first lag as a significant lag. And the PACF plot also shows the first lag as significant lag. The ADF and PPE test now confirms that the process is different stationary.
We decided to use ARIMA modeling for model fitting and forecasting the data because this different series now shows no trend or severe changing variances. From the ACF, PACF, BIC, and EACF plots, we consider the possible models to be ARIMA 011, ARIMA 012, ARIMA 110, ARIMA 111, and ARIMA 112.
We then fit all the possible ARIMA models and perform the coefficient tests and find that ARIMA 110 has all its coefficients significant. Further, in the AIC and BIC testing, we see that ARIMA 110 has the least values in both of these tests. From the other error measures test, we see that ARIMA 112 has the least values for its error measures. However, it has the highest AIC and BIC values, and not all of its coefficients are significant as well. We can see that the error measures for ARIMA 110 are satisfactory, and hence we overfit the model and perform its residual analysis.
From the time series plot for ARIMA 110, we see that there is no trend and no seasonality. There are some changing variances, although not all of them are severe. We can see that there is one severe variance after 2020, which may be due to the presence of an outlier, and this presence can be further seen in the histogram and the QQ plot. The histogram and Shapiro test shows that the residuals are not normally distributed, but this is due to the presence of outliers. The QQ plot suggests that the residuals are normally distributed and also confirms the presence of outliers. The ACF plots of the residuals shows that there is no significant autocorrelation, which is good. The junk box test shows all the p-values above the reference line and further confirms that there is no significant autocorrelation in the residuals.
And hence, from all the analysis done, we can conclude that ARIMA 110 is the best fitting model. So we use this model for forecasting the monthly food retail industry turnover for the next 10 months, that is, from April 2023 to Jan 2024, as seen here. Thank you for listening.